Okay, so this is lesson 39, inequalities in a triangle. And once again, these will be here for you to copy into the charts. The first one, theorem 39.1, says that a triangle's largest side is always opposite to its largest angle. See, largest side, opposite largest angle. And then vice versa. Its smallest side is always opposite the smallest angle. So, over here, where it says order the angles from least to greatest, do you see right here how 12 is the smallest of the three? That means the smallest angle is opposite. So we're going to write angle W first as the smallest, comma. Now, the next smallest is 19. Would you agree? So we're going to look opposite of that. And what angle do you see?
V.
Correct. Angle V, comma. And then obviously the last angle is angle X. So this is the answer to number 1. Would you please take a couple seconds to do 2 through 4, same way, least to greatest? All right, Kellen, number 2, please.
Angle R, then angle Q, then angle P.
Do y'all agree? Beautiful job. Gabby, number 3, please.
Angle L, angle N, angle N.
Do y'all agree? Yes?
Yeah.
Okay. Harper, number 4, please.
Angle D, angle E, angle C.
What y'all think? DEC, do y'all agree?
Yes.
Okay, beautiful job. All right, now let's look at theorem 39.2, where it says the sum of the lengths of any two sides of a triangle must be greater than the length of the third. Okay, that is actually down here. So let me go over this first, and then we'll go back up here, because I didn't realize that we were going to cover the opposite of the sides, which are the angles. Okay, so down here, it's saying that when you're given two sides of a triangle, so you see here 6 and 6, to find what the third side could possibly be, we're going to use a range. Okay, so write this down for me. Do 6 take away 6 less than x less than 6 plus 6. Take a second to examine this, because I know I went kind of fast. First of all, you're always going to have this in the middle. Do y'all see that? Less than with x in the middle. And then on the left, you're going to subtract these two numbers. And on the right, you're going to add those two numbers. So do you see the pattern of what I did there? So now we're going to solve it. 6 minus 6 is 0. Rewrite the less than x less than. What's 6 plus 6? 12. This is the range. The third side can be anywhere in between 0 and 12. It can be 1 all the way to 11. It can't be 0, and it can't be 12. It has to be between those two.
So that's the answer?
That's the answer. That's the range of possible measures for the third side. So you're always going to start with the between, and then you're going to do the minus of those two numbers and the plus of those two numbers. So try that for 10, 11, and 12. And then if you have time, do me a favor and come back up here, and this time do the sides. So like the answer to this one is side ST, side US, and then side TU. See how I put them in order from least to greatest based off of the opposite? So this one, then this one, then this one. So finish this page for me, and then we'll go over it and make sure you got them all right. You have questions, Gabby?
No.
Okay. You were looking at it like, what, Miss Davis?
Yeah.
I can help you if you need help.
And then you said to do these if we have time.
Yes, please. This time we're ordering the sides. You know how before we ordered the angles? On 1 through 4 we ordered the angles, and now for 5 through 8 we're ordering the sides. Same thing, but be careful, because look, notice how I labeled it with the segments as opposed to the angle symbol.
Miss Davis, how
Yeah.
did you get ST?
Oh, because if you look across, so you see how 40 is the smallest?
Mm-hmm.
So you look across ST. So that side's the smallest. And then across from the 60, because 60 is the next smallest, right?
Mm-hmm.
So look across. You see the US?
Mm-hmm.
And you could have written SU.
Okay.
They mean the same.
Wait, do you do these minus themselves, or do you?
Yeah, 10 minus 9, perfect. And then 10 plus 9, perfect.
Okay. And then for this one right here, I would do. So it would be ZY. You look there.
ZY is the largest, right? Because the 80, see how 80 is the biggest?
I thought if you looked across, that would be ZY.
So
40.
across from 40, boom, this side.
So it's YX.
Yep. Okay, so you want to subtract those two numbers and add those two numbers. See how we added and subtracted those two numbers? So we're going to do 10 minus 9 on the left, and then 10 plus 9 on the right. Make sense?
Yes.
So for 60, you would look right there.
No, you go across. Boom.
Oh, okay.
Opposite. As if you're drawing a line directly across.
Would you do 9 minus 10 or 10 minus 10 minus 9?
You always want to do what's going to give you the positive number.
Okay.
So don't subtract in a way that's going to give you a negative. Okay, let's start with ordering the sides from least to greatest. Okay, Logan, number 6, please.
I got YX.
YX, and again, XY would work too.
Then I got ZX.
ZX,
And then I got YZ.
YZ. Double check, see if y'all got this. That's from least to greatest. All right, Harper, number 7.
SR.
SR, okay.
Line TS.
TS,
Line TR.
TR. Check up here and make sure you got it right. Kellen, number 8.
I didn't finish 8.
That's okay.
So for 30, you would it go straight down? So it'd be DF.
Perfect. Keep going.
First is 25.
Oh, wait, 25's first.
So 25 would go straight up, right? So it'd be ED.
ED. Okay.
And then 125 would be.
Well, hold on. Shouldn't 30 come next?
Oh yeah, but it was DF.
DF, okay.
And then 125 would be EF.
Yeah, lovely. Is this what y'all got? Perfect. Okay, now moving on to the ranges. We already did the first one where we subtracted these two numbers and added these two numbers. So let's move on to number 10. And I think, Gabby, we left off with you.
Yes, it would be in between 0 and 21.
0 and 21. You're right about the 21. Because 11 plus 10.
1.
Yeah, there you go. She said it. 1. Why? Because 11 minus 10 is the 1, right? And 11 plus 10 is the 21. Okay, back to you, Logan. Number 11, please.
Between 1 and 19.
1 and 19. Let me double check you. So 10 minus 9 is in fact 1. And 10 plus 9 is in fact 19. Excellent job. All right, Harper. Number 12, please.
Between 3 and 19.
3 and 19. 11 take away 8 is 3. And 11 plus 8 is 19.
You're always going to get a positive number.
Always.
So even if you have to like move like the 11
Uh-huh.
and the 8, you'll still get the.
You got it.
Okay.
Because you always want a positive number, because the third side of a triangle, it can't be a negative distance. It's got to be a positive distance. Okay, questions before we move on to the next lesson, lesson 40. We're good? All right, lesson 40. This is nothing new to you. Because y'all been in Saxon for so long, you've been doing these for at least 2 to 3 years now. It's called finding perimeters and areas of composite figures. Composite figures are just plain figures made up of simple shapes. So they pretty much put different shapes together, more than one kind, to see if you can find the perimeter in the area. Now notice the top one, they want you to find perimeter, right? And the bottom one, they want you to find area. So you want to be very careful that on the top, you're adding up all the sides. And on the bottom, you're finding the area within the shaded regions, right? And then down here, these should look familiar from Saxon. It's where they only want you to find the area of the shaded parts. So you're going to have to get creative. You're going to have to find the area of the whole thing and then subtract the area of the middle shape, right? You find the area of the whole square and then you subtract the area of the circle. Now, there's some formulas you're going to have to be familiar with in order to solve these types of problems. So like, for example, this one, aren't you going to need to know circumference to find that half circle, right? You're going to have to know Pythagorean theorem to find the hypotenuse. So you're going to have to be very familiar with formulas. So if you don't know those, you want to pull out your formula sheet and have those ready to reference when you're solving these. But I think you can tackle these, at least try a few on your own, and then we'll go over them together. So give that a try. And don't feel like you can't ask questions as you're working. This isn't a test or anything. I just want to see how much of it you remember without us going over it. Because none of this should be new to you, though it might
So you just add
be
all
helpful
these
to
up,
have a
right?
review. Yeah, for that first one, you're absolutely right. You're going to add every single side. And they were nice enough to give it to you. Whereas on these two, they want you to find info first before you can add all the sides.
And you said to do all of them?
Yes, please. At least the ones you feel confident about. If there's one you start working and you feel that you get stuck or you're not sure, you can either skip it or ask me to give you some guidance to get you going.
So for this one, would you use pi r squared?
So pi r squared is for area. You're going to want to use circumference, which is 2 pi r. But we only want half of that.
So then we divide it by 2.
You got it. Because 2 pi r would give you the whole circle.
But how do I know what the what this equals? Like,
See at the very bottom how it tells you that that is a 5?
Mhm.
That means the radius is going to be half of 5.
okay.
Miss Davis, would you like that?
Okay, so then you did 2 pi r divided by 2. But you don't need this here. So just erase this and then you'll be good. Punch that in your calculator carefully. And you might even want to